I'm Anil Kumar. Welcome to my YouTube channel. Let me thank all my students, subscribers, and viewers for watching my YouTube channel and participating actively in contributing with brilliant questions. These days, I've been getting some requests from grade 11 students who are appearing in Waterloo math contest. So here are a few request questions from previous test papers, and I hope their solution will help most of you. Sorry for the bad print, the ink is running out, and since the contest is tomorrow, I thought I'll first go with the solutions and then get a new ink cartridge. Well, the question here is, a cylinder has radius 12 and height 30. So here is your cylinder. So as we go along, I'm going to complete my diagrams and explain you, right? So radius 12, so we are saying this part radius 12 and height of 30, so let's say this height is 30. That is for the cylinder, correct? The outside. The top circular face of the cylinder is the base of a cone, as you can see very clearly, and the center of the bottom circular base of the cylinder is the vertex of the cone. So that becomes the vertex of the cone. A sphere is placed inside so that it touches the cone. So that's the sphere which is touching the cone at 2 points. The base of the cylinder and the side of the cylinder as shown. Which of the following is closest to the radius of the sphere? Okay, so we need to find the radius of the sphere, and let's say this is the radius r. That's the question for you. Perfect. So you can always pause the video, answer the question, and then look into my suggestions. Now, let's look into this. These are the 2 points of tangency of sphere with the other surfaces. So let me just make this. So that would be 90 degrees, and that is also r for us. So we get this. Okay. Now, what else? We get this point also, which is also r. So that becomes the radius of the sphere, and these are the points. What you notice is that we can actually find this 30 and this 20. We can find the slant height of this cone. So let me label this. Okay, so let's label this as A. Let's label everything A, B, C, D, right? So let's say EF. Okay, and these points G, H, and I. Let's see how it works out. Okay, so all this is labeled now. We can actually calculate what A to F is using this right triangle. Correct. So let's make us few guidelines. 2-dimensional figure. So we are working on this side, and we are now figuring out what is this side. A to F. Very less space to solve this particular question, so I'll squeeze in many things here, right? So AF is square root of, that's the hypotenuse, correct? Longer side. This is 12 and this is 30, right? That's equal to this side. So it is square root of 12 square plus 30 square. Now calculator is allowed for the math contest, so we'll use the calculator. So we'll have square root of 12 square plus 30 square. That is 6 square root 29. So let's have decimal value. Okay, so we'll have this as 32.311. Let's approximate. Right. Since the answers are given in decimal values rounded to 2 decimals, I am taking decimal values rounded to 3 decimals at present in my calculation. Okay. Now, so we know this whole length, but we also know that this is combination of these two. Okay. So combination of these two. So we know that these two lengths, A to G and A to H, should be same. So it is tangents from external point, right? So let me write down this important theorem, which is tangents from external point. have equal length. Okay. So that gives us that A to G is equal to A to H. Now, A to G, we know this is R, right? So A to G could be considered as 30 minus R, right? So that becomes 30 minus R. Clear? So this whole length is 30. Taking away R will give us A to G. Clear? So that means this is also 30 minus R. Right. Now we need to find what is G to H to F. This is what we need to figure out. Now how can you find that? Okay. Now look from this side. That is your external point, and we have a tangent here. And this is also tangent. Correct? So using this theorem, which is very important theorem. So many contests will use this theorem in some way or the other. So from here, we can say that F to H, let's use this, F to H is equal to this side, right? So F to H is equal to F to I. And this whole distance, since that is R, right, this portion is R, correct? And the whole thing is 12 radius, correct? So it is 12 minus R. So we get this, F to H. Simple. Now as you can see that A to F is basically sum of A to H and H to F, right? And A to F we calculated 32.311 should be equal to A to H, which is 30 minus R, plus H to F, which is 12 minus R. So we get our equation, and which is 32.311 is equal to, when you add them, you get 42 minus 2R, correct? So that should help you to find the correct answer. So I hope we are close to it now. So we can say that we can take this on the other side. So we get 2 times R is equal to 42. Take away 32.311, or R is 42, take away 32.311 divided by 2. Let's use calculator once again. So 42 minus 32.311, so it is divided by 2, half, right? 4.8445. So 4.84 is the correct answer, right? 4.84, which is option A. Correct. So we get our answer, which is option A, which is 4.84. Correct. So that is how you're going to find the answer. So once again here, the most important theorem which works for you is that the length of tangents from external point is equal. And once you look at this question from this angle, it becomes easier to solve this. I hope that makes sense. Feel free to write your comments, share your views, and if you like and subscribe to my videos, that'd be great. Thanks for your time and all the best.